All right, so for this one, this is called the power rule. And notice what happens is if you have n outside of the parentheses and m inside as a power, all you do is you distribute that n power, multiply that by m, okay? So I'm going to show that on the next example. So I'm going to multiply. This is implied to be x to the first. This is y to the second. So when I distribute, the x becomes x to the fourth. And 4 times 2 is 8. So y to the 8th power. So there's the first example. Second example, this is 3 to the first power. So then distribute 3 to the first times the third is 3 to the third. And then 8 to the third, and then you multiply that by 3, that becomes 8 to the ninth. And then this one here is b to the third, so that becomes b to the ninth. But then 3 to the third is 3 times 3 times 3, which is 27. So this is 27, 8 to the ninth, b to the ninth. And that's the answer to this problem. Okay, all right, next one, number 3. So for this one here, we have two expressions that are being multiplied together. So I'm going to multiply, I'm going to distribute this fourth power. Okay, so this becomes 2 to the fourth. And then 3 times 4 is x to the 12. And 4 times 8 is y to the 32nd power. Okay, so that's this one for now. And I still got to do the other one. So I'm going to distribute this fifth power. So this becomes x to the 35th power. And this becomes y to the negative 10th power. Okay, so then I'm going to simplify this. 2 to the fourth is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, right? So then this becomes 16. And now notice I'm going to do this right away. When I combine x to the 12th times x to the 35th, that's actually the product rule. You just add the exponents. So 12 plus 35, that's 47. So x to the 47th power. And then y to the 32nd minus the 10th power. That's y to the 22nd power. Okay, so then this is the answer to that problem. Again, you can always pause the video and go back or rewind if you did not understand what I just said here. Right, the next one, negative times negative, that makes this 2. Well, before I do that, let me just distribute. So this is 2 to the first. So then that becomes negative 2 to the third power. And then this becomes x to the, it's 3 times 2, which is 6. Okay, and then this is, let's see, I'm going to distribute that fifth. So negative y to the 10th power. Negative times negative, this implies to be a negative 1, so that becomes positive. Okay, then, oh, and let's do 2 to the 8th power. So 2 to the 8th is the same as, let me just write it down. So I have negative 8 x to the 6th power, okay, times negative y to the 10th power. Again, this is not necessary, but in case you don't see it, negative times negative is positive 8. And then we have x to the 6th, y to the 10th, and this is the answer to that problem. All right, next example. So for this one, we have, so this is where we apply this also. The basis must be the same. And then what I'm going to add here, add, subtract powers, and then for this one, you're just combining, okay, so combine like terms. Okay, for this part. For this one, number 5, number 6, and number 7. So then I have 3x to the second times y, and I have 7x to the second times y. I have x times y to the second. So notice here we have x to the second, y to the first, y to the first. So what I can do is just combine these two, because these two are like terms. So it's like saying 3 plus 7, which is 10, x to the second, y to the first, plus x times y squared. Okay, and that's as far as I can go. Again, because the 3 and 7 are like terms, but this one is not, because it has y squared instead of x squared. Right, that's the first example. So for this one, I need to first distribute this power to the second term. So then I'm going to do that. So this is x to the 6th. This becomes y to the 4th. Okay, so then I have 7x to the 6th, y to the 4th. And now look at these terms. Are they like terms? So this is x to the 6th, y to the 4th, x to the 6th, y to the 4th. This is implied to be one term. okay? And this one is 7 of them. So then when you add them together, they become 8x to the 6th, y to the 4th, and this is as simple as we can get with this example. All right, next example. For this one again, I'm going to distribute the second power, so I'm going to keep this x to the second for now. Okay, then distributing, this is x to the first, so this becomes x to the second. This is y to the third, so it becomes y to the sixth, applying the power of a power rule. Okay, plus I'm going to keep this y square, and then I'm going to distribute this power. So this becomes x to the fourth, and then this becomes y to the fourth power. So then what I'm going to do next is distribute this one here. So now we're multiplying. So you're just adding exponents because this is this rule, okay, the product rule. So then this becomes x to the fourth, y to the sixth, and then this becomes so plus x to the fourth, 2 times 2 and 4 combined to 6, so y to the sixth. Now notice this is one term, and this is another term, and they are like terms because this is x to the 4, y to the 6, x to the 4, y to the 6. So then you add them together to combine 2 times x to the 4th times y to the 6th. And this is the answer to that problem. Okay, I hope this wasn't too difficult. If you have any questions, don't forget you can always ask us questions in the classroom. I'll see you in the classroom. Thank you for watching. Bye-bye.